try to go beyond even the domain that Einstein successfully described, when we try to put quantum theory into the story, which Einstein did not do, we do find that general relativity gets modified. Now, it could also be that quantum mechanics gets modified. This is an idea that people are talking about today. So that would, again, fit into exactly the same template. Earlier ideas, when you try to go further, require new concepts, new ideas. They have to be modified.
Do you think that there is a sentimentality in physics where people kind of want to cling on to these famous revolutionary ideas because, as well as them being really impressive as theories, they're exciting, you're familiar with them. And so when you're faced with something that causes you to abandon something so familiar, do you think there is a psychological barrier for a lot of physicists?
I think it's really depending on which physicist you're talking about. So are there some in the history of physics where you can find reasonable evidence that they were reluctant to take the new step because they were so tied to the old way of looking at things? Yes, you can even in some way say that about Einstein in some ways. When quantum mechanics came along and was suggesting that the best you could ever do is predict the likelihood, the probability of one or another outcome, very different from the classical perspective that Einstein was used to, where you tell Einstein how things are today, and Einstein will tell you how they will be tomorrow with 100% certainty coming from the mathematical equations. When quantum mechanics began to chip away at that picture, yes, is there some evidence that Einstein resisted it? Absolutely. But I would say that the dominant perspective of most physicists, including Einstein himself,
welcome to watching
is
me
that
eat.
It is so exciting when there is a radically new way of thinking about the world. And so I would say the dominant way in which physicists approach their work is that they look for the opportunity to take us to a new place.
And that's what string theory creates the option for. Because if we have, let's just say, in general, okay, that this applicator, right, ends up being, for example, let's just say a quark, right? That quark has whatever it is, right? We just call this quark 7, right? Now, within this quark, we have the makeup of it. Regardless of it, we have the coordinates. We know this is a quark here, right? Then in